Now, let's look at this coastline fit. So one of the arguments against the coastline fit was about coastlines are always areas that are changing. You know, you in the winter, especially when we have El Nino winters here in California, you hear about, you know, landslides, homes sliding into the ocean and the coastline changing. So meteorologists, oceanographers, well, you know, the coastline's always changing, right? But what people didn't realize, and this really didn't come out till the 1950s after the World War II data was declassified, is that the edge of the continent is not the shoreline. The true edge of the continent is really this, this thing called the continental shelf. And the continental shelf is a submerged area of the continent. It's underlain by felsic rock, and it goes out to about 600 feet deep, which is about 200 meters. And then it drops off to the deep ocean where you get to the ocean basin. So the true edge of the continent is the true edge of continents are the continental shelves. So one of the arguments also against Gondwana here is that the coastline between Argentina and South Africa, well, that doesn't fit at all if you look at the coastline. But if you look at the continental shelves, the fit is perfect. It is just, you know, so adding the, you know, and again, people didn't know this in the 1920s. In fact, I didn't mention this, but Wegener proposed this hypothesis in 1914, right? So the drift hypothesis was proposed in the 1914s. That's when the book was published. And it was argued through the 1920s and finally rejected. But the data for the seafloor really didn't come out till the 1950s. And then that kind of started the revolution with plate tectonics, as we'll see later on. Now, as we go along here, let's look at the glaciations, right? So we talked about these concordant glaciations. So what does concordant mean? Concordant means to confirm, right? So when you look at the present day glaciations here, right? When you look at these, we say these are discordant because, and the reason is, remember when glaciers travel over bedrock, they're scratching and leaving grooves on the bedrock, and those are called striations, right? These striations right here. So, so the striations in India show that the glacier was moving from the ocean onto land. In Australia, they show that the glaciation shows, or striations show that the glacier is moving from the ocean to land. Same thing over here with Argentina, right? So that's impossible. We know glaciers move from higher elevation to lower elevation. So this is discordant, right? It's discordant. However, what Wegener proposed is well, here are the glacial striations, these scratches right here. So what Wegener proposed is, well, let's reassemble Gondwana. And when he reassembled the continents, he noticed, to his surprise, that it seemed like there was a glacial mass over South Africa and Antarctica, and the ice was moving out in all directions. So now, when you do the reconstruction of Pangaea, well, really in this case, Gondwana, we find that the glacial striations are concordant. So that's what I mean by the word concordant. So they make sense. And they only make sense if you reassemble the continents. And also note that Gondwana was close to the South Pole, right? So it was at higher latitudes in the southern hemisphere where you can get these colder climates. So that was part of his paleoclimate study as well. Now let's look at the next criteria. So this is the climate belts, right? Paleoclimate. So late Paleozoic rocks preserve evidence of ancient climate belts, right? So when he reassembles the continents here, so near the equator, you're going to have belts where you're going to see tropical rainforests, coral reefs, coal deposits, limestone deposits. These little brick patterns mean limestone, right? If you go to higher latitudes, around 30 degrees north or south, you get deserts, right? So the desert latitudes. And if you go to really high latitudes, you'll see the glaciations, right? So, so what do we got here? We got desert, tropics, reefs, right? We got some reefs. So remember, limestone is a very, coral is a rock composed of the rock called limestone. And that limestone rock is composed of a mineral called calcium carbonate, and it's a rock called limestone. We'll get into that as we go along. And then here we have the sand dunes for desert. So by reconstructing the climate belts, it makes sense here with having, in this case, really Gondwana, more so than Pangaea here. Now, as we go along here, the other one were these fossils, right? So we've talked about Lystrosaurus and the Mesosaur and the Cynognathus, and then we see the zones for the seed fern and Glossopteris here, right? Now, as we go along, the rock records, right? So late Paleozoic and early Mesozoic, similar rock records on Gondwana land. So this is across ocean basin. So especially if you look between South Africa and South America, Brazil here, we see that we have at the bottom here we have this tillite, right? And so a tillite is you'll see that glacial till. Till is a rock deposited left behind by a glacier. So these are those glaciations, right? So note they're about, so the Carboniferous here, this is about 320 million years ago, right? And then we get into we see the same Mesosaur fossils, right? The same shales here across continents. We have sandstones, and then they're all capped by the same basalt, right? And so this is again showing the similar rock records. And then the other piece of evidence were the distinctive mountain belts, right? So you have mountain belts that trend from Africa into South America, and you can link up. So we haven't talked about these terms here. So Archean is one of the earliest eons of geologic time. It's basically the earliest Earth. So the Archean was a time when the first rock started to form from this molten Earth that started to get warm enough and finally started forming rocks. So these are older than 2.5 billion years old. Proterozoic rocks are also really old, and they're anywhere from about 542 to about 2.5 billion years old, so a little bit younger. So, and the key thing about these Proterozoic belts, they're usually they came after because you're going to suture these Archean small continents, right, along these suture belts that are Proterozoic. But when you reassemble Gondwana, you see that the mountain belts conform. It makes sense there. Okay. And here's another one showing some mountain belts in the northern hemisphere, with the Appalachians and the Atlas Mountains of Africa, and here combining with some of the mountain belts that you see in Europe as well. All right, so let's stop here for now.